The Parramatta Engineering Innovations Hub showcases forward-thinking technology, yet its current design includes several flaws that hinder effective study and work. Through 5 showcases, ranging from noise pollution and unreliable Wi-Fi to room booking inefficiencies, a central problem emerges. The space lacks the flexible and functionality students need to thrive. This proposal addresses core issues by recommending targeted design improvements inspired by the Sticky Campus concept and successful layouts from other universities. These changes aim to enhance comfort, connectivity, and collaboration, ultimately transforming the PEIH into a more effective and engaging learning environment. The current layout of the PEIH prioritizes tutorials and classes, but overlooks the need for a quiet Wi-Fi reliable study areas. Thick walls and doorways disrupt internet connectivity, whilst hallway noise and limited study spaces further hinder students' ability to work effectively. Through mind mapping, these issues were identified as core problems connecting several case studies together. A well-designed university space should support both learning and independent study. By improving layout flow and embracing Sticky Campus principles, the PEIH can become more welcoming, functional, and a student well-being focused campus. This case study adopts a qualitative approach, observing firsthand how the building's design flaws affect students' ability to study effectively. It aims to understand the experience from a student's perspective, focusing on comfort, accessibility, and productivity within the Parramatta Engineering Innovation Hub. First-hand research was conducted by measuring Wi-Fi strength across the campus, assessing noise pollution in the central hallway and study rooms using decibel readings, and calculating the ratio of available to fully booked study spaces. These findings offer a grounded view of the current student experience, which will be discussed further in the results section of this proposal. To validate these observations, second-hand research was also conducted. This looked into the academic benefits of strong Wi-Fi connectivity and exploring how other universities design their campuses to enhance comfort and engagement. This is what's known as a sticky campus. A Bolden network study found that 85% of students experiencing connectivity issues report negative impact on their academic performance and well-being. A stable internet connection is vital, especially for students without reliable Wi-Fi connection at home. Unfortunately, the PEIH's current Wi-Fi coverage and layout does not support a sticky campus model. The lack of comfortable, engaging study areas also makes students less inclined to remain on site beyond class hours. In contrast, universities like James Cook and the University of Newcastle have created a flexible, student-focused environment that promotes well-being and academic success. If the PEIH is to meet similar standards, we must reimagine its design with connectivity, comfort, and engagement at its core. Through the research carried out at the PEIH, it showed how the design/layout of the campus negatively affected students. The study focused on 3 key factors: Wi-Fi strength, noise levels, and the availability of study spaces. The findings revealed critical design flaws that impact students' ability to learn and collaborate effectively. Measurements across the building showed that thick walls and closed doors significantly disrupted Wi-Fi signal. Download speed ranged from 64 megabytes per second to 164 megabytes per second, with upload speed between 18 megabytes per second and 46 megabytes per second. Classrooms located deeper in the building had noticeably weaker signals compared to more open hallway areas. Given that the optimal download speeds are around 100 megabytes per second, many areas within the PEIH underperform. Hallway study tables showed stronger connection, whilst enclosed classrooms lag behind. These inconsistencies highlight the infrastructure problem that limits digital access for students. Noise levels were also measured and found to vary widely. Hallways averaged 64 decibels, peaking at 82 decibels, an environment that is loud and distracting. Study rooms, by contrast, were significantly quieter, averaging 38 decibels and peaking at 42, which is more suitable for academic concentration. Despite the suitability for focused work, study rooms were often unavailable. On average, 7 out of 9 rooms per floor were booked or occupied. This shortage limits access to quiet spaces and reveals a need for more efficient and student-centered spatial planning. These findings suggest that the current layout of the PEIH does not meet students' needs. To address this, design changes should prioritize flexible learning spaces, community zones, and collaborative areas. Such environments better support diverse learning styles and student well-being. A strong reference example is the University of Newcastle's amphitheatre-style computer lab. Featuring circular seating and shared desktops, the space promotes collaboration, making it ideal for group projects and study sessions. It demonstrates how design can enhance academic interactions. Adapting similar multifunctional spaces within the PEIH could provide a better balance between study and social needs. Redesigning internal layouts and removing signal blocking walls would improve Wi-Fi distribution while increasing flexibility in how spaces are used. Creating designated zones for group work could help reduce hallway congestion and noise. This would free up quiet areas for independent learners, improving the overall functionality of the building, but would require major renovations. With these improvements, the PEIH could evolve into a more engaging and supportive academic space. Better connectivity, thoughtful design, and inspiration from peer institutions could help create a sticky campus, one where students choose to stay, study, and thrive.